Hello, hello, hello. I wanted to do a video on differential equations about just to get the idea out there about just elementary or basic substitutions. So sometimes these aren't particular substitutions, say like y equals vx for a homogeneous equation, but sometimes you just look at the differential equation and you say, well, this factor sticks out and it's kind of ugly. Let me just replace it with some other variable. As a very basic example, if I were to give you dy over dx is equal to x plus y, you could say to yourself, well, there's a number of ways to solve this, really. For example, the way that is more mechanized, so to say, we could move the y to the other side, and this is equal to x. And this does fit the form dy dx plus p of x y is equal to q of x, where q of x is just x and p of x is -1. So we could find the integrating factor mu of x, which would just be e to the negative x, and we could go through and multiply this whole equation by e to the negative x. That's one way to go about solving the differential equation. The other thing is that this is also a Bernoulli equation, because this is really a y to the 0 here. So you could solve it that way too. There's a number of different ways to solve the differential equations. And those are slightly more complicated ways, but you can also make this differential equation, you can make it, if you look at it, I mean, you can make it separable. What's the only thing sticking out to you? It's this x plus y, right? If this weren't a plus, if it were just one term, then the equation would be separable. So you could say, well, I'm going to let z be equal to x plus y. And then dz is dx plus dy. So dy, I'm going to multiply by dx on both sides, is z times, now dx is dz minus dy. And now this equation is separable. Dy is equal to z dz minus z dy. So 1 plus z dy is z dz, and you can go from there about solving it. But so that's the idea, is getting a equation into a nicer form by just looking at, well, what stands out to me? That's really the idea here. There is, let's see if I can find it. I had it, I swear I had it. Give me a second. Okay, yeah. All right, now this is a big step up, but it really isn't. It just looks that way. So 2 times y minus 1 times x plus y minus 1 plus y minus 1 squared dx plus 4 times y minus 1 times x plus y minus 1 plus x plus y minus 1 squared dy is equal to 0. Now, this might look intimidating, and there is a good bit of algebra that needs to happen here. But, I mean, look at the factors. I mean, what stands out here? There is... So you could do two things here. You could say, well, I could let, say, z be equal to y minus 1, and then say w equal to x plus y minus 1. Of course, it might be a little more efficient to write just that the factor of x plus y minus 1 is just z plus x. And now what you could do is you could make it 2z times z plus x plus z squared dx plus 4z times z plus x plus z plus x squared. And now dy, well, we know dz is equal to dy, so we can just replace the dy with dz is equal to 0. Now that looks a lot better to me. It's a lot nicer. Personally, I mean, this is probably where your mind would go originally, is just do this one substitution, since I can express x plus y minus 1 in terms of z easily, just add x to both sides. But it really might be a little better, actually, to introduce two variables and say w be equal to x plus y minus 1. Because then it cleans up even nicer, I think. Because now this z plus x, that's just w. W. And, whoa. And w. Of course, you do have to write dx in terms of either dz or dw, because you can only have two variables. So it doesn't really matter which one you pick. I would pick a dw here. So dw is dx plus dy, and that makes dw equal to dx plus dz, because the dy is dz, so then dw minus dz is equal to dx. And so you would just replace this dx with dw minus dz. And if you notice, I'm not going to solve this differential equation now, but I mean, you, I hope, noticed that now the resulting equation is homogeneous for degree n equals 2. If I were to plug in tz and tw, see, all the exponents add up to 2. This is a 1, this is a 1. 1 plus 1 is 2, that's a 2. This is a 1, this is a 1, that's a 2. So you could just do the substitution. You could do z is equal to w. Z is equal to vw, or w is equal to vz. Either one would work, and they would both work just as well. You just got to remember the product rule. So dw would be dz, or vdz plus zdv. But however you want to do it, this equation is now homogeneous, which can then be turned into a separable one, and so you can solve it from there. The whole point I'm trying to make is that if you see a differential equation and there's a big factor jumping out at you, and it happens more than once, or if it happens just once if there's only one factor, it's a really good idea to just substitute that factor in for something smaller and to simplify it, just like how you do u substitution.